Hello everyone, this is Cameron Snow with Danomics.com. In this video, I'm going to be reviewing how to use the built-in Python interpreter in the Danomics Flows toolkit. So let's get started. As you can see, I've already logged in here to the Danomics platform. And to get started, what I'll need to do is I'll need to create a new flow. So I'm going to say File and select New Flow. This will bring up a menu. And I'm just going to name this Python Example Flow and hit OK. It then creates this file here in the file tree, and you'll see it brings up a new file type. So if you remember correctly, flows are a way to perform batch operations, and they are built with small blocks, small tool blocks. So first of all, we need to get data into our flow. So we can either click New or we can just start typing. So I'm going to start typing and say log input. So we have our log input block. Then we're going to have a Python block. And finally, we're going to end with a log output block. So let's go through and review each of these blocks before we dive into the Python in detail. So starting with the log input, this is what gets log data into the flow. So we are going to start here by choosing a database. And then once you've chosen the database you'd like to perform the operation on, you can tell it which wells to operate on. So either all the wells, a specific list of APIs, or a points file that contains APIs. We're just going to operate on all the wells for this one. For our Python block, this is a simple code block, and we'll go into this in much more detail. And then finally, we have our log output where we give it a name. So I'm just going to call this Python example flow output because I want it to be clear exactly what we're writing out here. So with that said, we can now save our flow. But let's take a look at the Python code here in detail. So this is a very simple script that is just an example, and it's how you would calculate a vclay from gamma ray. So let's walk through each of the elements of the code. Here on the first line, you can see we have an import that's from this internal Danomics library import flow. This is just something that needs to be there to tell the Python interpreter that we're running this as part of a flow. Next here, you'll see that we have our tool definition. So this comes through as a class, and this class is expanding the base tool method. We have an optional update block here, and then we have the block where the actual work is done, and then finally we have this call to the tool which will actually tell the class to execute. So let's take a closer look here in the execute block, as this is where you'll be doing most of your work. So first of all, we say if not log, return none. So what that means is if the object passed in is not a log, we're basically going to exit this block. So that's what this means, and this is important for having in there, so once we've reached the last log, we will exit our Python code. This next line here says gr, so gamma ray is equal to log.get underscore curve. So get curve is a method on the log object here, and we are telling it to get the gr curve from any well that's present. And then we're saying if gamma ray is none, so essentially if there is no gamma ray curve in this well, we are going to return the log object and then move along to the next well. If it is present, we are then going to set the values for gamma ray clean and clay, which we've assigned to be 20 and 100 here. You can make this any value. And then we're going to say vclay from gamma ray is equal to our gamma ray curve minus gamma ray clean divided by gamma ray clay minus gamma ray clean. So very simple equation here. This is the same method that we use in the CPI file. And then finally, we are going to write this data back to the log. And you'll notice here we're saying log is equal to log.setCurve. So set underscore curve is a method on the log object. One thing to note here is we have to use this log equals log.setCurve. And the reason why is logs are an immutable type, so we need to write over that. And then within setCurve, we have the name of the curve that we want to write out, and we have the values that we're writing out, vclay from gamma ray. Now, you'll probably want to assign units to this, and we can add units by saying units equals, let's say, decimal in this case, and we can also give it a description by saying description is equal to, let's say, vclay from gamma ray. Now, once I've typed this in, we're ready to run this. And finally, after we've written to the log object, of course, we're going to return that log back to the database and move to the next well. So when I hit play here, it will then pop open the jobs menu, and then it will initialize. Now, note the first time that you run a flow, it will take a minute for it to initialize. And the reason why is we are essentially building the Python environment. You'll notice that runs pretty quickly, and when we click on this, we get a job log that shows us how, what it is that we've executed, as well as how many logs it acted on, and how many curves. So you'll notice here we input 46 logs with 570 curves, and we got out 46 logs with 605 curves. This means 35 of our wells had a gamma ray, and we've now created this vclay from gamma ray. You'll also notice that over here on the left-hand side in our file menu, we now have this database that we created. And if we click on that, we can get a preview where we can see that this vclay from gamma ray has been created in a number of the wells. Okay, so that is a very simple example, but I know you're thinking, hey, I want to do some more advanced operations. So let's take a look at a tool that we have built in Python as a demonstration for this. So I'm going to start by creating a new flow. So once again, File, New Flow, and I'm going to call this Python example 2, and I'm going to hit OK. And once again, that creates a new flow, and you'll need to put in a few building blocks here. So we're going to start with log input. Then we're going to use one of the example tools that we built. And we're going to use this null repeated log samples as our example. And then we're going to have a log output block. So let's set up each of our blocks. So here in the log input block, once again, I'm just going to select this database. Just note that this is a Python-based tool. You can tell by the icon type here. And then for our log output, I'm going to say Python example 2. And once again, I'm just going to put output on there so I'll know where this is coming from. And then we can save that. And so now we're ready to run. But let's take a close look at this null repeated log tool. So when I click on this, you'll notice that we have now two tabs here. We have a menu tab and a code tab. So that menu tab is something new. And you'll see this menu has a drop down here, which log do we want to evaluate. And it has a list of all the curves that are available to us. We're going to act on the gamma ray curve again. You'll notice that we also have this use alias table checkbox here. So that's also something new. And we have a radio button group for do we want to edit top, base, or top and base. And then finally we have a few inputs like what are the number of repeated samples and the value tolerance for each of those repeats. So you're probably wondering, hey, how is it you have a menu on here? Well, let's take a look at the code to find out. So here over in our code, you'll notice here at the start, we have something that may look a bit unusual for those of you who are used to Python, and that is this menu setup that we've built. And now this is something that is custom to Danomics. but you know, it is something that that will work if you are creating your own Python block. So let's look through this. So first of all, we're giving our tool a name. So we're calling it null repeated log samples. And then we have a parameter definition. And here we've laid out a number of parameters, and the syntax of this is exactly the same as that which we use in the YAML file formats in our Petrophysics. So here we have a creatable select menu. What does creatable select mean? It just means that you can start typing here, and you could use any curve type. So that's what that creatable select is. We have this checkbox for use alias table, which is what we have right here. We have our edit mode, which is the radio group, and then we have the minimum repeated samples and the value tolerance. And notice we've given all these a type. So the radio group returns a string, the repeated samples returns an integer, and that'll become clear as we walk through the code. And the value tolerance returns a double or a float value. Then we have our imports. So we're going to be using the NumPy library. So we're going to import NumPy. We are going to import this typing because we want to make sure that we have the right variable types coming in. And then we have a number of tools that are internal to Danomics, such as our flow and the flow context. Importantly here, you'll see that we are importing our parameter resolver, as well as this required alias set tool. So once we have our imports, now let's jump into the tool itself. So you'll see that we are referencing a number of these parameters that we just set up. I would encourage you, when you're building out your first menu, to try to just recreate something that we have already done. And then as you become more comfortable with it, you'll be able to build more advanced and customized tool sets. So here you can see we are taking our alias table, and this is a true or false. It's a Boolean parameter, and we're using this annotated tool that we imported up here. Well, for our edit mode, this is a string parameter. And then for the minimum repeated samples, it's an integer. And for our value tolerance, it's a float. And then for this alias set, we're using this custom internal type called a frozen set, which is a variation of a string. This define update self method within our class, this is what populates our alias table and returns to us a list of curve mnemonics. So when we select gamma ray, this will now take all the gamma ray alias curves. So for example, the GRR curve would be something that would now be included in that instead of just gamma ray by itself. And then finally, we are going to execute this. So we're going to create a variable called tops and base. And this is based on that radio button that we created. We are going to have this same block here. So if not log, return none. So that says, hey, if it's not a log, let's just skip it and potentially exit the block. And then we're going to have where we execute the code here. And basically, we're going to do a loop over the log. So for example, if you have both a gamma ray and a GRR log, so GR and GRR in the same well, it would run this block twice, once for each of those curves, and then we will return that log. Now, one thing to notice here is I'm calling this function perform trim top and base, and this is just a standard Python function, and that function is defined below our tool call. This function takes a value of curve, our value tolerance, our minimum repeated samples, and booleans here for trim tops and trim tails. Now, where are those coming from? So trim tops and trim base is coming from here, and we are putting it into the function here. Minimum repeated samples, this is coming from our parameter as well as the value tolerance is. And curve, we are once again getting with this log.getCurve method. Once we've used this, it's just standard Python. So, here we're just using the NumPy library, and we'll run through a code block. And notice when we write tools for you, we try to do a lot of error checking in here. So we're going to check, is your curve, less than the minimum number of repeated samples? Are all the values null values? Are all the values identical? And we're checking those for you up front because that will help eliminate errors. And then once it passes all those checks, it will then run through the code block where it will essentially evaluate if we have repeated values. It'll then null those values out and then return that modified curve. And that modified curve is then written back to the log object using the setCurve method. Now, you'll notice here that I'm not setting the units, and that's because when you update an existing curve name, it will maintain the units and description for you. And then once we have done this, you will have this menu that's available to you where you can use the menu now to inject parameters into the Python code as opposed to having to go into the code like we did here and manually set these parameters. So if you're writing code for your colleagues or coworkers that you want to have distributed more widely, this is a good way to do that. And we can just hit the play button here, and once again it'll go through the initializing, running, and then finished block, and it will return to us a new database. So I hope that is useful to you. As you're getting started trying to write some of your initial Python tools, I encourage you to look at the examples and try to understand this and try to replicate some of the work we've done before taking on some more advanced use cases. And as always, remember that we are here to help you. You can email us at support@danomics.com or visit our website and submit a support ticket through our contact form. All right, thank you for tuning into this, and I hope it has been useful to you.